Hello, good morning. Today I am going to explain the NEET PYQs from 2025. So, today our topic is redox reactions from chemistry. So, what's our first question is consider the following compounds. There are given three compounds are there. First one is KO2. The first compounds is KO2, H2O2 and H2SO4. So what we have to do here, we have to find out the oxidation state of the underlined elements. We have to find the oxidation state of the underlined elements. We have to find out. So here in this first question, we have to underline the K, not the oxygen. We have to underline the K here, not the oxygen, and next H2O2 and H2SO4. So the oxidation state of the underlined elements respectively. So first, what is our question in this KO2? For the KO2, we have to find the oxidation state for the KO2. Oxidation state for KO2. KO2. In this, we have to find the oxidation state of the potassium. Actually, potassium is a alkali metal. Potassium is a alkali metal. Alkali metals always show which oxidation state? +1 oxidation state. Alkali metal always show the +1 oxidation state. Okay. So the oxidation state of the KO2, oxidation state of the KO2, in that we have to find the K. What is the K oxidation state here? Potassium oxidation state is +1. KO2 is called as the superoxide. KO2 is called as the superoxide, and in this for the oxygen exists here as a -half oxidation state. Here oxygen exists as a -half oxidation state. Next is our H2O2. H2O2. In this, we have to find the oxidation state of the oxygen. So here, how many hydrogens are there? Two hydrogens. Each hydrogen oxidation state, it will be +1 plus how many oxygens are there? Two oxygens. 2 into, we have to find the oxidation state of the oxygen. So 2x equal to 0. 2 plus 2x equal to 0. So 2x equal to -2. So what will be our answer? X equal to -1 will be our answer. So what is the oxidation state of H2O2? In that H2O2, in the oxygen oxidation state, it will be of -1. Next, we have to find the oxidation state of the H2SO4. We have to find the oxidation state of the H2SO4. In this, we have to find the oxidation state of the sulfur. We have to find out. So, how many hydrogens are there? Two hydrogens are there. Each hydrogen oxidation state is +1 plus sulfur we have to find out. So x plus 4 into what is the oxidation state of oxygen? -2 equal to 0. So 2 plus x minus 4 2 is 8 equal to 0. X minus 8 minus 2 equal to 6 equal to 0. So x equal to what is the oxidation state here? +6. Okay, the H2SO4 oxidation state is +6 and H2O2 oxidation state is -1 and KO2 oxidation state is +1. So what we have to check in our answer? +1 -1 +6. +1 -1 +6. Okay. So +1 -1 +6 is our answer. +1 -1 +6. So it is showing in the option 1, that is +1 -1 and +6. Okay, so our option is 3. So next we move towards the next question. Here what they are asking, the oxidation state not shown by manganese in the given reaction is. We have to check the oxidation states of the manganese here. We have to check the oxidation states of manganese here. And what is the oxidation state not we are not getting, that is our answer. So I can do it. So first of all, we can find the MnO4 2 minus oxidation state for this. In this manganese oxidation state, we have to find X plus 4 into, how many oxygens are there? 4 into minus 2 equal to minus 2. X plus 4 2s are 8 equal to minus 2. So X equal to, what is the oxidation state? 8 minus 2, it will be 6. So MnO4 2 minus oxidation state will be MnO4 2 minus MnO4 2 minus oxidation state, it will be 6. Next, what is there? MnO4 minus is there. MnO4 2 minus completed, MnO4 minus. So we can do the oxidation state of MnO4 minus. In this, what is, we have to find the oxidation state for the manganese. X plus 4 into minus 2 equal to, here, minus 1. So X equal to 4 2s are 8 minus 1. It will be how much? It will be plus 7. So we are getting the plus 7 also we are getting. Plus 6 also we are getting. Next, we have to find the oxidation state of MnO2 here. Next, we have to find the oxidation state of MnO2. So MnO2 here we have to find. This MnO2 manganese, X plus 2 into minus 2 equal to 0. So X equal to how much? 4. So what we are getting here? Plus 6 also we are getting, plus 7 also we are getting, and plus 4 also we are getting. But only two options we are not getting in this. What are the two options? That is plus 2 we are not getting and plus 3 we are not getting in this. So what is our correct answer here? B and E. B and E is our correct option. So D is our answer. B and E, D is our answer. So what they said, the most appropriate answer from the given below not shown by the manganese. Plus 2 is not shown by the manganese and plus 3. So what is our option? B and E is our option. Okay. Next, we move towards the next question. Which reaction is not a redox reaction? What they are asking in the question, which reaction is not a redox reaction? What is, first of all, we have to know the what is redox reaction. We have to know what is redox reaction. In this, oxidation and reduction takes place simultaneously. Oxidation and reduction takes place simultaneously. This is called as the redox reaction. Okay. So which reaction is not a redox reaction? They are asking. Which reaction is not a redox reaction? So we can check which reaction is not a redox reaction. What is our first reaction? Zinc plus CuSO4 gives rise to ZnSO4 plus Cu. So here, what is the oxidation state of zinc in the elemental? Whenever it is present in the elemental state, the oxidation state will be 0. And here also copper is present in the elemental state, the oxidation state is 0. And in the copper sulfate, what is the oxidation state? It is getting plus 2. And in the zinc sulfate, it is getting the oxidation state plus 2. So what I said in the redox reaction, oxidation and reduction takes place simultaneously. So from CuSO4 to Cu, what happening? Decrease in the oxidation state is called reduction. Plus 2 to 0. Plus 2 to 0 is called as the reduction. Means here what happened? Decrease in the oxidation state, and from the zinc to plus zinc 0 to plus 2, means here increase in the oxidation state is called as the oxidation. It is the oxidation, increase in oxidation state from 0 to plus 2, and copper sulfate CuSO4 plus 2 to 0, means here oxidation also takes place and the reduction also takes place simultaneously, so it is a redox reaction. Okay. Zinc, it belongs to the which group? Zinc belongs to the group 12. Zinc belongs to the group 12 metal. So it always form a plus 2 ion oxidation state in most of the compounds. Most of the compounds it show the plus 2 oxidation state. So this is our zinc first option. This is our redox reaction. Next, while we are moving towards the next option, our B option. What is our B option here? KClO3. 2 KC, here iodine is in the I2. I2 is Z. Here what we are getting in the iodine, I2 is present in the elemental form. I2 is present in the elemental form, means it is getting a zero oxidation state. I will show you. 2KClO3 plus I2 gives rise to 2KiO3 plus Cl2. Okay. So here chlorine is in the elemental form, it is zero oxidation state. Iodine is in the elemental form, it is of zero oxidation state. Here KClO3 we have to find out. For the chlorine, we can do, what is the oxidation state of a potassium? Here plus 1 plus x plus 3 into minus 2 equal to 0. 1 plus x minus 6, 3 2s are 6 equal to 0, x minus 5 equal to 0, x equal to plus 5. So what is the oxidation state in the KClO3 is plus 5. Next, if we can 2KiO3, in this potassium oxidation state is same, that is the plus 5. In the place of a chlorine we are written the iodine just. Okay, plus 1 plus x plus 3 into minus 2 equal to 0. 1 plus x minus 6 equal to 0, x minus 5 equal to 0, x equal to plus 5, means here KClO3, KiO3 is getting the oxidation state, that is plus 5, and iodine is in the elemental form, chlorine is in the elemental form, so it is getting the oxidation state 0. So if we can see KClO3 to, it is from Cl2. So decrease in the oxidation state, that is plus 5 to 0. It is called as the reduction. It is called as the reduction. Next, from the I2 iodine to 2KiO3. Here increase in the oxidation state from 0 to plus 5 is called as the oxidation, means here oxidation and reduction takes place simultaneously, so that's why we call it as the redox reaction. So our B option is also a redox reaction. Next, if you can see the H2 plus, third option, if you can see H2, third option, if you can see H2 plus Cl2 gives rise to 2HCl. So here H2 is in the elemental form, 0 oxidation state. Chlorine is in the elemental form, 0 oxidation state. Here hydrogen is getting the plus 1 oxidation state and chlorine is getting the minus 1 oxidation state. From H2 to H, it is going to increase in the oxidation number, we call it as the oxidation, and from chlorine 0 to, it is going to be a minus 1, so increase in the decrease in the oxidation state, we call it as the reduction, means in this option also oxidation and reduction occur simultaneously, so this is also our redox reaction. Next, so we can see our D option, we can see our D reaction, BaCl2 plus Na2SO4 gives rise to SO4 minus 2 gives rise to BaSO4 plus 2Na plus Cl minus. So here sodium is having a plus 1 oxidation state, chlorine is having a minus 1 oxidation state, and in this barium is second group element plus 2 oxidation state. SO4 is having a minus 2 oxidation state. Here also barium plus 2 oxidation, chlorine minus 1 oxidation, and the sodium first group, so plus 1. So here if you can see, there is a no change in the plus barium sulfur BaCl2 to BaSO4, that is plus 2 minus 1, and Na2SO4 also plus 1 minus 2, means here there is a no change in the oxidation state. So it is not a redox reaction. What it is, this is a not a redox reaction. In this there is a no change in oxidation state. So if you can check the barium plus 2 plus 2, chlorine minus 1 minus 1, sodium plus 1 plus 1, SO4 minus 2, SO4 minus 2, means here there is a no change in the oxidation state. So what the reaction is called? This is called as the double displacement reaction. What the reaction is called here? Double displacement reaction. It is not a redox reaction, this is a double displacement reaction. So what is asked in the question? Which reaction is not a redox reaction? All the A, B, C options are the redox reactions, but only the one option is there that is not a redox reaction, that is BaCl2 Na2 SO4. BaCl2 Na2SO4 BaSO4 plus 2NaCl. Here H2 plus Cl2 gives rise to 2HCl. Next here Zn plus CuSO4 gives rise to ZnSO4 plus Cu. Here 2KClO3 plus I2 gives rise to 2KiO3 plus Cl2. So what is our not a redox reaction? This BaCl2 Na2SO4 BaSO4 to NaCl, means here there is no change in the oxidation state, so this is not a redox reaction, so this is called as the double displacement reaction. So our D option is correct, which is not a redox reaction, means this is our D option is not a redox reaction. So next we move towards the next question. The correct option for the redox couple is, the correct option for the redox couple is what they are asking. Both are, first for option A, both are oxidized forms involving same element. First of all, what is redox reaction? I said earlier, oxidation and reduction takes place simultaneously. Okay, so both are not oxidized, this is not a correct option. Next, both are reduced, no, this is not a correct option, this is not a correct option. In this, both are oxidized also not correct, both are reduced also not correct. Both are reduced and oxidized form a same element, yes, it's going to be a correct option. Next, cathode and anode together, it is not a correct answer. So both the reduced and oxidized form involve the same element, means must be a here two different oxidation state. In this, it has to be must two different oxidation state will be there. What is a redox couple? A redox couple means, a redox couple is typically represented by, it is typically represented, how it is represented means by separating oxidized and reduced form, by separating the oxidized and the reduced forms by vertical lines, by a, which lines here means by a vertical lines, by a vertical line or slash we can represent by this. So if you can see the example, so what I said, what is a redox couple? A redox couple is a redox couple is how it is typically represented? It is typically represented by separating oxidized form and reduced form. Oxidized and reduced form. How it is separated by oxidized and reduced form means by a vertical line or slash. By a vertical line or slash. What is the example? Best example, if we can see examples like zinc, 2 plus 2 zinc, this is we can say, and copper, 2 plus 2 copper. So here both are reduced and oxidized form the same element. Means what is redox couple? Means it is typically represented by separating oxidized and reduced form by a vertical line or by the slash. If you can see example like zinc plus 2 zinc, Cu plus 2 Cu, means in this what happening, the what is our correct option? The correct option for redox reaction means both oxidized and reduced to form the same element. So what is our correct option here is the C is our correct option. Next, if we move towards the next question. On balancing the given redox reaction, the coefficient A, B, C are found to be. Here what we have to do, we have to balance the redox reaction. What we have to do here, we have to balance the redox reaction. So we can do balancing the redox reaction. In that we can, what is the coefficient we are getting, like A, B, C, that is our answer. So I can write here what is our oxidation of reaction and reduction of reactions. Okay, oxidation of reaction and reduction of reaction. Okay, oxidation of reaction and reduction of reaction. Okay, I am writing here oxidation and reduction. So what is our first in this SO3 2 minus to SO4 2 minus. Next in the reduction it is Cr2O7 2 minus 2. How many? Cr3 plus. First of all, what we have to do, we have to balance the atoms other than oxygen and hydrogen. So here how many chromiums? 2. Here only 1 chromium, so I am adding the 2 chromiums. Next what we have to balance, we have to balance the oxygens by taking the help of water molecule. Here how many oxygens are there? 3. Here how many oxygens are there? 4. Means we have to add how many oxygens? 1. How the oxygen is added? With the help of a water. So SO3 2 minus plus how many oxygens we have to add? 1. 1 oxygen with the help of 1 water molecule we have to add. SO4 2 minus plus 2. Next, by balancing the hydrogens, how many hydrogens are there here? 2. Here how many hydrogens? No hydrogens, so we can add the 2H plus 2 hydrogens. Next here how many oxygens are there? 7. In this product side there is no oxygen, so how many oxygens we have to add? 7 oxygen. 7 oxygen with the help of 7 water molecules. Cr2O7 2 minus gives rise to 2Cr plus 3 plus 7H2O. Next how many hydrogens are there? 7 2s are 14. Here is there any hydrogen? No hydrogen, so 14H plus. Next what we have to do, we have to balance the number of electrons. Electrons we have to balance. So 4 minus 2 we have to add the 2 electrons. 2 electrons we have to add. So SO3 2 minus plus H2O gives rise to SO4 2 minus plus 2H plus. How many electrons we have to add here? 2 electrons. Here 14 minus 2, it will be 12. Okay, it will be 12 here. Next 2 3s are 6 here. 12 minus 6, total 6. Means we have to add how many electrons? 6 electrons over here. Cr2O7 2 minus plus 14H plus plus 6 electrons we have to add, gives rise to 2Cr3 plus 7H2O. Next, what we have to do, we have to balance the electrons on both sides. Here we have a 2 electrons, here we have a 6 electrons. So how we can balance? We have to multiply this total equation into 3. 2 3s are 6 and this into 1 only. Okay. So if we are multiplying this equation with the 3, what we are getting here? 3SO3 2 minus plus 4H H2O gives rise to SO4 2 minus plus 2 3 into SO3 3SO3 3 into H2O 3H2O 3 into SO4 3SO4 3 into 2 6 H plus 3 into 2 6 electrons. Next we are writing same as it is this one. So this is our oxidation, this is our reduction. So we have to cancel this. So how many electrons are there here? 6 electrons. 6 electrons getting cancelled. Next, how many hydrogens are getting cancelled here? Here 14 hydrogens are there, here 6 hydrogens are there. Means here how many remained hydrogens? 8 hydrogens are remained. Next, water. Here how many water are there? 3H2O. No? So here how many are there? 7H2O, 3H2O cancel, means here remained how much? 4H2O. So we have to write the total balanced equation, that is 3SO3 2 minus plus Cr2O7 2 minus plus how many hydrogens remained in this? 8 hydrogens. 8H plus gives rise to how many SO4s are there? 3 SO4 2 minus plus what is remained here? 2Cr3 plus what is how many H2O is remained? 4H2O. So what they are given in the question, what they are asking in the question for us, coefficients of A, B, C they are asking. A means what is our A? Cr2. How many Cr2 is there here for us? Only one Cr2 is there, only one chromium is there. So Cr2 how many is there? 1. Next, and in the B what they are asking? SO3. Cr is 1 and B SO3 is how many moles here? SO3. Chromium is 1 mole, SO3 is 3 moles. SO3 is 3 moles. SO3 2 minus is 3 moles are there. And next, hydrogens. Hydrogen, how many hydrogens are there here? 8 hydrogens. Means what is our answer? 138 will be our answer. 138 is shown in the which option? D option. 1 Cr2O7 2 minus and 3 SO3 2 minus and 8 H plus. 138 is our option. So which is our correct option out of these? D is our correct option. So what is our correct option in this? D is our correct option. So here how many Cr2O7s are there? Only 1. And SO3s are how many are there? 3 is there. 3 and C is how many hydrogens are there? 8. So 138 is our correct option. D is our correct option. So next if we can move towards the next question, which of the following reaction is a decomposition redox reaction? What they are asking in the question, decomposition redox reaction is asking. So what is decomposition redox reaction means? First of all, we have to know what is decomposition redox reaction. A single reactant, in this a single reactant break down into 2 or more products. Breaks down. Single reactant break down into how many products? 2 or more products. Okay, single reaction breakdown into two or more products. Change in oxidation state takes place. The one element is oxidized and other element is reduced. If a change in oxidation state takes place, change in oxidation state takes place means one element is oxidized and other element is going to be reduced. Okay, so what is decomposition redox reaction? A single reactant break down into two or more products. In the change in oxidation statement, it is oxidized and one element is oxidized and the other element is reduced. One element oxidized and other element is reduced. This is called as the decomposition reaction. So we can check the explanation. We can see what it is the which reaction is our decomposition redox reaction. So if you can see the first option, the P4 plus 3OH minus plus 3H2O PH3 plus H2PO2. So this is called as this reaction is called as the disproportionation reaction. This reaction is called as the disproportionation reaction. Why it is called as the disproportionation reaction means the same element is oxidized and reduced by involving the multiple reactant. In this the same element, the phosphorus is same element. Which element? The same element means phosphorus is oxidizing and reducing by involving the multiple reactants. By involving in the multiple reactant, the same element is going to be oxidized and reduced. Okay, so it is the A option is called as the disproportionation reaction. Next, if you can check the B option, that is PB. Here PB is getting a oxidation state of +5 and here NO2 is getting a oxidation state of +4 and this is total 1 PbNO3 2. This is getting a +5, NO2 is getting a +4 and O2 is in the elemental form, it is getting a 0. Means here single compound lead nitrate breaks into, this is the single compound. What is the name of this compound? Lead nitrate. This breakdowns into three compounds like 2PbO, 4NO2 and O2. Means here single compound breakdown into three products. Here the single compound breakdown into three products. From this here to +4 +5 to +4 means decrease in oxidation state happens. This is called as the reduction and from +5 to +5 to 0, +5 to 0, it's what happening here? Oxidation. It is oxidation and this is reduction. Here reduction is happening and oxidation is also happening. So the following reaction is a decomposition redox reaction. What I said, decomposition redox reaction, a single reactant break down into two or more products. Here single reactant is lead nitrate. This is breaking down into three products like PbO, 4NO2 and O2 by undergoing the oxidation and reduction. So this is our decomposition redox reaction. And next, if you can see the option 3, if you can see, this is called as the N2 plus O2 gives rise to 2NO. This is called as the combination reaction. What it is called here? We called it as the combination reaction. Combination redox reaction we can call. Here two elements are combined like N2 and O2. Two elements N2 and O2 combines to give rise to a single product. So what we called it as the combination redox reaction. Next, if you can see the last D, Cl2 plus 2OH minus gives rise to ClO minus plus Cl minus plus 4H2O. So this is called as the disproportionation reaction. We called it this reaction as the disproportionation reaction. Why we call this disproportionation reaction? Where chlorine is here simultaneously oxidized. Chlorine is simultaneously oxidized to ClO minus and oxidized to ClO minus and reduced to Cl minus, and it is reduced to oxidized, it means 0 oxidized from Cl to ClO minus and reduced from Cl to Cl minus, means here chlorine is oxidized and reduced. So it is called as the disproportionation reaction. So what is our question? Which of the following reaction is a decomposition redox reaction? Decomposition redox reaction means a single reactant break down into two or more products. Change in oxidation state takes place in one element oxidized and other element is reduced. We can see this in the lead nitrate. One element, one compound break down into three compounds. Okay, so what is our correct option? According to this question, decomposition redox reaction. Which of the following is a decomposition redox reaction? Means this reaction is a decomposition redox reaction. Option B is our correct option. Next, well, let us move towards the next question. What is the change in oxidation number of a carbon in the following reaction? So we have to check the oxidation state of a carbon in this reaction. We can check. So here CH4. CH4 means what is the, we have to find the oxidation number of carbon here. X plus 4 into minus 1 equal to 0, x equal to 4. Oxidation of carbon is here, what it will be, minus 4. Next, here what is oxidation number? It is getting minus 4. And in CCl4, x plus carbon means x plus 4 into minus 1 equal to 0. So x equal to 4 minus 1, 4 into minus 1, it is getting plus 4, means it is changing from minus 4 to plus 4. Oxidation number of carbon in the following reaction is changing from minus 4 to plus 4. So we have to check the option B, minus 4 to plus 4. We are getting which option is right for us? Minus 4 to plus 4. Carbon oxidation state is changing from minus 4 to plus 4 in the B option. So our B option is right. Okay. Next we move towards the next question. Which of the following reaction is a disproportionation reaction? Which of the following reaction is a disproportionation reaction? First of all, what is disproportionation reaction? I said in the earlier also. What is disproportionation reaction means? The same substance undergoes oxidation, means increase in oxidation number, and reduction, forming two different products. What is disproportionation reaction means? The same substance undergo oxidation and reduction. Oxidation means increase in oxidation number and reduction means decrease in oxidation number by forming how many products? Two different products is called as the disproportionation reaction. We have to check what is the same substance that is undergoing oxidation and reduction by forming two different products. We can check. So we can check the first option. What is our first option? Copper. 2Cu plus gives rise to Cu2 plus Cu. So here copper is getting plus 1 oxidation state and here copper is in the elemental form 0. Here it is getting the +2 oxidation state. Copper is +1 +2 0. See, +1 to 0 is called as a plus, here +1 to +2 is called as a Redox oxidation. Increase in oxidation never +1 to +2 is called oxidation. Here +1 to 0 means it is called as a reduction, means the same element, same substance here undergoing oxidation also, copper undergoing reduction also. Oxidation by Cu +1 to +2 and reduction by +1 to 0. So first option is our disproportionation reaction. First is our disproportionation reaction. Next, if you can check this second reaction, if you are going to check here MnO4 means here manganese will get the +6 oxidation state, and next here it is getting a +7 oxidation state, and here manganese will get the +4 oxidation state. Okay, so +6 to +4, here decrease in oxidation state means reduction, and next Mn +6 to +7 means here increase in oxidation state means oxidation, means here also the same substance MnO4 plus is MnO4 minus is oxidized and reduced. Oxidized by +6 to +7 and reduced by +6 to +4, means it's undergo oxidation also and reduction also. This is called as the disproportionation reaction, means option 1 and 2 both are disproportionation reaction. Next, if you can check the option 3, here 2 KMnO4 means here manganese is getting which oxidation state? +7. Here manganese is getting +6 oxidation state, and here it will get the +4 oxidation state. So if you can check here +7 to +6 also +4 also, means here only decrease in the oxidation state takes place, only reduction. There is no increase in the oxidation state from the reactant to the products. +7 to +8 +9 is not going, just reduction takes place here, means here oxidation state is going to be decreased from reactant to products from Mn +7 to +6 and +4, means here only what happened, only reduction takes place here, only reduction takes place here. So this is not a disproportionation reaction. Next, if you can check the next last option, here it is getting +7 oxidation state, here it is +2, and here it is getting +4 oxidation, means here also +7 to +4 means decrease in oxidation state, only reduction takes place, means this is also not a disproportionation reaction. This is also not a disproportionation reaction, means which of the following reactions are disproportionation reaction? The same substance undergo oxidation and reduction forming the two different products is called as disproportionation reaction. It's happened in only A option and B option, so it is happening in these two options. So A and B is our correct options. A and B are our correct options. So B1 is our correct option, that is A and B is our correct option. Next, so what is our correct option in this question? Which of the following reactions are disproportionation reaction? Means A and B are our disproportionation reaction. Next, we move towards our next question. The correct order of N compounds in its decreasing order of oxidation state. Correct order of N compounds in decreasing order of oxidation states. So we can do correct order. First of all, we can write the oxidation and reduction of reactions. Oxidation of reaction. The correct order of N compounds The correct order of n compounds in its decreasing order of oxidation states. Okay, the correct order of n compounds in its decreasing states. First of all, we can check the oxidation states of a oxidation states we can check. I am writing the oxidation state of HNO3. HNO3. In this for the nitrogen we have to find the oxidation state. So 1 plus hydrogen 1 plus a nitrogen X plus 3 into minus 2 equal to 0. 1 plus X plus 3 2s are 6 equal to 0. X equal to 6 minus 1, it is 5. So what is the HNO3 oxidation state? It is 5. Next, if we can check the NO. So x plus minus 2 equal to 0, x equal to plus 2. Next, if we can check the NH2. N2 is in the elemental form, it is 0 oxidation state. Next, if we can check the NH4Cl. So in this nitrogen, x plus 4 into plus 1 into minus 1 equal to 0, x plus 4 minus 1 equal to 0, x plus 4 minus 1, it will be 3 equal to 0, x equal to minus 3. So what is our oxidation state in NH4Cl? That is minus 3, HNO3 5, NO2, and in the N2 0. So correct decreasing order is first HNO3 is first decreasing order, first 5. Next after that NO is plus 2. Next third is our N2, that is 0. Fourth is our minus 3, least order minus 3. Okay, so what is our correct decreasing order? Means HNO3 5 and NO2, N2 0, NH4Cl minus 3. So what is our oxidation states here? HNO3 is 5 plus HNO3 is plus 5 and NO is plus 2, N2 is 0, and for NH4Cl it is minus 3. So correct decreasing order is our first option, that is HNO3, NO, N2, NH4Cl. So what is our correct option? A is our correct option. Next we are moving towards the next question. That is, for the redox reaction MnO4 minus plus C2O4 2 minus plus H plus Mn plus 2 plus CO2 plus H2O, the correct coefficient of the reactants for the balanced equation. Here they are asking the coefficient. For that, what we have to do? We have to do the oxidation and reduction of reactions here. Okay, so I am doing the oxidation of reaction, that is oxidation of reaction and reduction of reaction. In this oxidation of reaction, C2O4 2 minus 2 CO2 and reduction of reaction MnO4 minus 2 Mn plus 2. So here how many carbons are there? 2. Here only one carbon is this, so we have to balance. C2O4 2 minus 2 2CO2. Next here MnO4 minus means here how many oxygens? 4. Here there is no oxygen, so we have to add the oxygen with the help of water. So MnO4 minus plus MnO4 minus gives rise to Mn plus 2 plus how many oxygens we have to add? 4. 4 with the help of water, 4H2. How many hydrogens? 4 2s are 8. Here there is no hydrogen, so 8H plus we have to add. Next we have to balance the electrons. Here 2 electrons are there are no electrons here, so I am adding the electrons. C2O4 2 minus gives rise to 2CO2 into 2 electrons. Here how many electrons are there? Here 8 minus 1, 7. 7 minus 2, it will be 5 electrons we have to add. 5 electrons we have to add. MnO4 minus plus 8H plus 5 electrons gives rise to Mn plus 2 plus 4H2O. Next we have to balance the number of electrons. Here 2 are there, here 5 are there. Means if we are multiplying this whole equation with into 5, 2 5s are 10, and this with the 2, 5 2s are 10, means we can get the number of electrons 10. 5 2s are 10, 2 5s are 10. So we can write the total equation here. 5 into C2O4, 5 C2O4, 2 minus 5 into 2, 10 CO2 plus 5 into 2, 10 electrons. Next here 2 into MnO4, 2 MnO4 minus plus 2 8s are 16H plus 2 5s are 10 electrons gives rise to 2 Mn plus 2 plus 2 4s are 8H2O. So we can cancel out the reaction. So in this, what is 10 electrons? 10 electrons get cancelled. 10 electrons get cancelled. Next, all remaining are same. 5 C2O4, 2 minus plus 2 MnO4 minus plus 16H plus gives rise to 10 CO2 plus 2 Mn plus 2 plus 8H2O. So what asking in the question? MnO4, C2O4 and H plus. MnO4, C2O4 and H plus. They are asking. For the MnO4, what is, how many MnO4s are there for us? There are 2 MnO4s are there. How many MnO4 are there? 2 MnO4s are there. And next, how many C2O4s are there here? 5 C2O4s are there. And for how many H plus are there? 16 H plus. Means MnO4 is 2, C2O4 is 5, 16. We have to check the 2, 5, 16 answer. So we can check the answer 2, 5, 16 to 5. Okay, second option is our 2, 5, 16. Means in our total balanced equation, MnO4 has 2, O4 minus are 2, C2O4 is O4 2 minus is 5, H plus is 16. So what is our correct option? Means B is our correct option. So next, next we are moving towards the next question, that is hot concentrated sulfate acid is moderately strong oxidizing agent. Which of the following reaction doesn't show the oxidizing behavior? It is question. So first of all, what we have to oxidizing behavior. Okay. So an oxidizing agent works by increasing the oxidation state. Oxidizing agent, how it is going to work? Oxidizing agent is going to work by increase the oxidation number. Okay, oxidation state, by increasing the oxidation state of which substance? Another substance, of another substance, while its own oxidation state is going to be decreases. If there is no change in oxidation state, the reaction is not redox reaction. If there is no change in oxidation state means that is not a redox reaction. Okay. So an oxidizing agent works by increasing the oxidation state of another substance while its own oxidation state decreases. If there is no change in oxidation state, then it is not a redox reaction and not show oxidizing behavior also. Not a redox reaction and not show oxidizing behavior also. So we can check the options over here. First option is our copper Cu. It is in the elemental form 0 and here 2H2SO4, it is in the +6 oxidation, here it is in the +2 oxidation state, and here it is in the +4 oxidation state. Here H2SO4 act as a oxidizing agent here. Okay, here it act as a oxidizing agent. Oxidizing agent here. Oxidizing agent is the H2SO4. It works by increasing the oxidation state of another substance while its own oxidation state is decreases. Okay. Next, this one here, sulfur is a 0 oxidation state, H2SO4 is the +6 oxidation state, and here it is of +4 oxidation state. So in this also H2SO4 act as a oxidizing agent here. Here H2SO4 also act as a oxidizing agent. Okay. Next, in this C option, this is a 0 oxidation state and this is of +4 oxidation state. In this also H2SO4 act as an oxidizing agent. Next, the last option CaF2 H2SO4. In this, if you can check, Ca is having +2 oxidation, fluorine is having a -1, H2 is having a +1, SO4 is having a +6 oxidation state, Ca is having a +2 oxidation, SO4 is having a +6 oxidation, HF in this hydrogen is having a +1, fluorine is having a -1. Means here Ca same, +2 to +2 only, F2 also same, -1 to -1 only, fluorine, and H2 also same, that is from H2. SO4 is also same, here +2, and SO4 in the reactant also 6, and the products also 6. Means here there is a no change in oxidation state. In this, no change in oxidation state takes place. So this is a double displacement acid base reaction. This is called as a double displacement acid base reaction. This is not a redox reaction. Why? Because there is no change in oxidation state. Here H2SO4 does not show oxidizing behavior. Okay, it is not showing here oxidizing behavior. In other than this, these A, B, C options, in that H2SO4 act as an oxidizing agent and showing the oxidizing behavior, but in the D option it is not showing the oxidizing behavior. So hot concentrated sulfate acid is moderately strong oxidizing agent. Which of the following reaction doesn't show oxidizing behavior? Means this D option is not showing the oxidizing behavior. Means here there is no change in oxidation state takes place and it is not a redox reaction. So what is our option? According to this, what is our option? D is our correct option. D is our correct option. Next, we are moving towards the next question. H2O2 plus O3 gives rise to H2O plus 2O2. Next, H2O2 plus Ag2O gives rise to 2Ag plus H2O plus O2. Role of hydrogen peroxide. H2O2 is called as hydrogen peroxide. H2O2 is called as hydrogen peroxide. Role of hydrogen peroxide in the above reaction is respectively. Here what happening for the H2O2 here they are asking. So we can see H2O2 in the above reaction. H2O2 plus O3 gives rise to H2O plus 2O2. Next, H2O2 plus Ag2O gives rise to 2Ag plus H2O plus 2O2. So we can check the oxidation states here. here it is of -1. Hydrogen peroxide oxidation state is -1, and here Ag +1, and here in the elemental form 0, here also in the elemental form 0. So here in this -1 to 0, -1 to 0 means it is decrease, -1 to 0, it is which agent here? Reducing agent. Agent is what? Reducing agent. So next, Ag2O2 2Ag. Here it is elemental form 0 oxidation state. Here also decrease in oxidation state, +1 to 0. Next, H2O2 to 2O2, -1 to 0 means here also what happening? Which agent it is? Reducing agent. Reducing agent. So role of a hydrogen peroxide in the above reactions is respectively. Here both are reducing agents. In the first reaction also reducing agent, in the second reaction also reducing agent. So our correct option is C. So our correct option is C. Correct option is C.